Greetings from Team Keep Learning. In this video, we will see variance and standard deviation as a part of measures of dispersion. So let's start. First, we will see what does variance means. So variance is a measure of variability. What variance used for? It used to see the variability of the data. It is used to see the variability of the data, how data is varying, and it is calculated by taking the average of square deviations from the mean. That means every time you will minus the mean from the value and you will take square of it, and then you can calculate the variance. I will show you the formula anyway in the next slide. And variance tells you the degree of spread in your data set. That means how far your data is from the mean, that you can see from the variance. Now let's see some figures. So in this figure, let's say red one is the mean value. The red dot is the mean value, and this data is clustered around the mean. So here I can say that it has a lower value of variance. Here I can say that it has a lower value of variance. But in this figure, as you can see, here is the mean value and the data is spreading far more at a far distance from the mean. So here I can say that it has a higher value of variance. It has a higher value of variance. Now we will see how to calculate the formula. I hope now you understand that what is population and what is sample. If not, you can just see the first part of this video series, and there I have clearly defined what is population and what is sample. So the formula for calculating variance is sigma square is equals to summation I equal to 1 to capital N xi minus mu square upon capital N. This is population variance. And when you are calculating variance for the sample, in denominator it will come n minus 1. It will come n minus 1. That I will explain you why it is like that. So summation I equal to 1 to capital N xi minus bar x square upon n minus 1. This is sample variance and this is population variance. Now we will see standard deviation. So if you want to calculate standard deviation, you simply need to take the square root of the variance. So sigma square was the population variance and s square was the sample variance. So we'll just take under root of it. We'll just take under root of it, and thereby we can calculate the standard deviation. So under root of summation I is equals to 1 to capital N xi minus mu square upon capital N, and if it is sample variance, in the denominator we will use n minus 1. I hope the formula is clear to you. Now we will see some important point about variance and standard deviation. First thing is that both are the measures of variability. We use both for measurement of variability, how data is varying in a distribution, but their expression units are different. Why different? Because standard deviation express the answer in the same units of the data set, because we already took under root and now the data units and the answer of the standard deviation units are same. But variance is expressed in much larger units because it is squared. So if the original value is squared, then of course answer will be in square. So that's why it is hard to interpret the units of variance. It is hard to interpret the units of variance because it is in square units, and it does not support our logic of calculating the same. So that's why we use standard deviation many times, often preferred standard deviation as a main measure of variability. But you have to keep in mind that variance is more informative about variability than the standard deviation, and it's used in making statistical inferences. When we will be going deeper into this, you will see that we are using variance more because sometimes we need not go for actual units. Sometimes we just need to see how the data is varying around the mean. In that case, we will use variance. Now we will see one example. So example goes like this. The owner of a particular restaurant is interested in how much money people spend at the restaurant. He is interested to know how much money people are spending at the restaurant. So he examines 10 randomly receipts for the parties and write down the following series of data: 44, 50, 38 to up to 46 and 50. Now here we have to calculate the arithmetic mean and we have to find the variance and the standard deviation of this data. Let's see. So first we will see the original data series. It is 4452 up to 4650. Then we will minus mean from all these data series. 44 minus 49.2, 50 minus 49.2, and so on. 49.2 is the mean. We have calculated mean by just adding all and dividing by 10, which came as 49.2. So we will minus mean from all the data series. We will minus the mean, that is 49.2, and then we will do square of it. X minus 49.2 square, so it is 27.04, 0.64 to up to 0.64. So the total is 2599.4. X minus 49.2 square, total is 25.99.4. So our formula of variance was S square equal to 2599.4 upon 9. Why I am taking 9? I am taking n minus 1. I am taking n minus 1 because this is a sample of 10 persons only who came to restaurant. There may be n number of persons would have come, and then the answer is 2599.4 divided by 9 equal to 289. So under root of 289 is 17. Under root of 289 is 17. So standard deviation is 70. Now what does it mean? How to write it? Usually we write this interpretation in terms of mean plus minus standard deviation. Mean plus minus standard deviation. So I will write it like this. Mean is 49.20 plus minus 17, plus minus 17. So one time I'll use minus, so it is $32.20, and one time I will use plus, so it is $66.20. So now the restaurant owner knows that people spend between $32 to $66 in his restaurant. This is how the interpretation goes on. So this is all about the measures of dispersion. If you have any doubt, any feedback or any suggestion, kindly direct it to the mail or comment it in the comment box below. Thank you.